in the middle of a revolution in how we get and use information, how we communicate with friends, family, and colleagues, and how we interact with technology. New powerful devices are making it possible to do things that would have been unimaginable only a few years ago. But these amazing devices often have small screens with awkward soft keyboards or very tiny keyboards, so the old ways of interacting with devices are no longer very comfortable or effective. We're now talking, using touch screens, and moving our devices to tell them what we want to do. We call these different ways of interacting with technology different modalities, and we call this interaction multimodal interaction. I'm going to talk about standards for multimodal interaction that have been developed by the World Wide Web Consortium, and I'm going to talk about how standards make it easier to create these multimodal systems. Let's back up a little bit and look at the trade-off between user experience and complexity in an interaction. We have this very complicated looking command prompt interface. It's technically simple, but it's a bad user experience. On the other hand, a good user experience like Google Earth on the iPhone is a very technically complex interaction, but it's a very good user experience. So as the complexity of user experience improves, the complexity of the underlying technology increases. Multimodality is a way to offer a more natural user experience than the traditional keyboard-mouse interface, but there are a lot of technologies involved in multimodal applications. We can divide the multimodal application into several different parts. We have the user experience itself, all the technologies for managing the interaction, capturing user input, capturing sensor data, for example, geolocation, and we have technologies for presenting output like the screen, audio, and even vibration. All these things are communicating with each other. There are many different devices and file servers in the cloud and the networks that support the communication, so we have all this complexity. We want to pull it all in for the user and present the user with a natural user interface so that for the user all the technology just melts away and gives the user a feeling of directly interacting with their application without constantly having to figure out how to do things. A multimodal application can include many kinds of input. The user may want to express their intent by lots of different ways: speaking, typing, the touch screen, handwriting, accelerometer that's moving the device. We may also capture, in some cases, just raw inputs like a photograph or a video or audio recording or a drawing. And we have sensor input like geolocation or specialized things like medical sensors that might provide information like blood pressure or heart rate. And then even another kind of input we might have is identification of who we are. We could have a fingerprint reader, face identification, speaker verification that identifies us just by their voice. Getting all these things to work together is complicated, but there are standards that can help with that. The W3C Multimodal Interaction Group has published several standards that will help us manage this complexity. So one way to make things easier is to represent the same information from different modalities in the same way using a standard, using a common language for representing the same information. This standard is called Extensible Multimodal Annotation, or EMMA. EMMA provides a uniform representation for multimodal information wherever it came from any kind of input, whether it came from speech, fingerprints, typing, touch screen. We can represent it. The reason we can do this is because EMMA includes general annotations, that is, general information about the input, as well as application-specific semantics, and we'll see what that means in a second. General annotations might include things like the confidence that the interpreter has in a result, timestamps, when it happened, and many other different types of annotations that represent the user's core intent, what the user wants to communicate to the application. Let's look at an example. Let's consider a travel application. The user says, I want to go from Boston to December on March 11th. And so we can represent the application semantics as a form. So you told the application what you wanted to do. We said, I want to go from Boston, I want to go to Denver, and I want to go on a certain date. This is the semantics of the user input. I could have said that by speech, or I could have input it with a mouse with pull-down menus and radio buttons, but the meaning is the same in both cases. In this case, the semantics is the same. In the case of speech, the medium is acoustic, the mode is voice. If it's mouse input, the medium would be tactile and the mode would be GUI. So it represents the same meaning in the same way, but it also represents how the user expresses that meaning. We can also do this with handwriting. We have the tactile medium and the ink mode, but we have the same semantics. I want to go from Boston to Denver on a certain date. So Emma represents the same meaning in the same way, but it also represents how the user expressed that meaning. We can also look at identifying users through biometric information. We might have the same identification with face recognition or with speaker identification. We're identifying the same person whether we identify them by voice or by their face. Emma represents the same identification in the same way, but it also represents how the identification was done. Visually by a photograph or acoustically by voice. Emma represents the same identification in the same way, but it also represents how the identification was done. We can also look at other modalities without going into too much detail: geolocation, typing, accelerometer, the position of the device. All of these can be represented in Emma. So to sum up, Emma reduces the complexity of multimodal systems by making inputs from different modalities look essentially the same. Here we have some more information. We have the link to the specification and more information about the Multimodal Interaction Working Group. Thank you.